2.3, let's do higher order derivatives. That's going to be your favorite topic. Higher order derivatives. What? Higher order derivatives. This is students' favorite topic, so I like putting it on a test because students just do well on that. Higher order derivatives means I want you to take more than one derivative. Usually, there's no way out of just taking more and more and more. You have to keep doing it, unless some kind of cases with sine and cosine, which are repetitive functions. So, I will show you something cool, and physics people will like it specifically. Like, let's take derivative of two different functions. You have original function y equals 5e to the x, do a bar, and let's do another one. Y equals 30x cubed plus 5x minus 10. Let's take many derivatives. And it's actually super fun. You should know that's students' favorite topic on calculus 1, 2, and 3. So I always put it everywhere. 3-dimensional, 5-dimensional students really good in taking higher order derivatives. So this is how we explain it. If you have, I don't have it here. The original one you can imagine is distance. So usually it's s of t. Well, in this case we have x, but it's fine. So s is distance. Original function. Let's take derivatives. So it's going to be y prime. What happens with 5e to the x? 5e to the x. How weird is that? Because 5 is multiplied by e, so it survives. E to the x gives you e to the x. But the second function, y prime, gives you
90x squared plus 5.
90x squared plus 5 minus 10?
No.
Because? It's constant. Amazing. So that's my first derivative. And notation is, so this was original function f, so that's going to be f prime. Some, if you want applications, that can be v, velocity. Velocity, speed. It's not the same thing for you to know, but we're going to explain it different later.
Velocity is a vector. It also has
Good job. Especially when we go to vector calculus, will be very cool. So what is derivative of velocity? Do you know?
acceleration.
A, exactly. Acceleration, double C. Acceleration. Acceleration. And that's called f prime prime. Second derivative. Let's find f prime prime. Y prime for the first function is
5e to the x.
5e to the x. It's like so boring. It's going to be 5e to the x, even if you take it lots of times. That's a cool, it's like how fast e to the x is. It's e to the x fast. So it's itself fast. And then times 5, it's times 5. But then when it comes to polynomials, they actually are shrinking.
180x.
180x. They are actually becoming more, they decrease the power. So they become more and more linear. The cubic function had like this kind of idea. It has 3 directions, up, down, up. It's a chair. The quadratic function has 2 directions, down, up, or up, down. The line has 1 direction. So the derivative here is doing something awesome. Where is my file? Now, do you know that we can actually move on? I think it's here. To more derivatives. Where's my notes for derivatives? Okay. So the third derivative, what is derivative of, so this is y prime. I guess the location is wrong. Let's put it a bit lower. That's, for example, acceleration. Let's continue with more derivatives. F prime prime prime.
180.
Jog.
Prime prime prime. Oh, let me put it not here. See, and my location is wrong. Yeah. Acceleration is the second derivative. Then f prime 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 180. What's the name?
Jog.
Jog. Yeah, it's somewhere in my notes and I forgot where is it.
Jog or jolt.
I think G O
Altitude.
We should Google. It's a physics term. I will search right now. It's actually somewhere in my notes. It is, I think, in this folder. Basic derivatives. Let me check. I have this. Some of my class I gave really cool. Maybe life sciences had a chance to actually check it out. Derivatives. Let's see. I said physics people will like it, and then I cannot find. Oh, I found it. Here it is.
Yeah.
So write down the third derivative is Jones. Jones. How cool is that? So you write down, and I will keep writing too. Let me take a picture. The fourth derivative is a jerk. That's a physics notation. So mathematicians, most of us, we don't know that by heart. My favorite one is crackle and pop. Again, imagine it's like how the speed is changing, how fast acceleration is changing, Jones fast, how fast Jones changing, jerk fast, and then at some point it's like it pops. That's how fast they change is happening. So let me go to my class. Here it is. Okay.
Ma'am,
Yes?
jerk is first and then Jones.
Jog is first one. I remember I followed Wikipedia though. Let me keep the notes like this. I'm not gonna use it anyways, so it's fine.
And then Jones.
My point is to keep going with the fourth derivative. Fourth derivative, we don't put 4 prime anymore. That's too many. How are you going to be doing 15 primes? That's too many too. So starting at 4, we put a number in the parentheses. No parentheses, it's a power. Parentheses is derivative. So this is first 4. Fourth order derivative. That's how it looks. That is going to be fourth derivative. So it is, we just checked, Jones. And then what is a derivative? What is the fourth derivative for this example? 0. What is the fifth derivative? 0, and so on. So it's because it's a constant. And if you're curious, let's have a cool note. F to the 5 was crackle. So that's how fast this acceleration changes, and then Jones changes how fast Jones is changing. Crackle fast. Then it pops, and then it's lock. We're never going to be using this. That's from physics, Wikipedia, part of physics. And as you can imagine, y to the 7th on the left is still 5 e to the x. And then it's going to be f to the 5 in parentheses, f to the 6 in parentheses, and f to the 7 in parentheses. You will also see notation in the book looking like so. The first, let me zoom in, the first derivative you saw df dx or dy dx, or dy dx. The second will be d2f dx2. The third derivative will be d3f dx3, and so on. So it's going to be d7f dx7. That's the other notation people use as well. I like parentheses more, but in upper level math we'll have to go to the second notation because we'll have more variables. So you can do that, right? That means if I give you example with distance and I ask you to find velocity, you take what? First derivative. Acceleration, second derivative. Simple as that. I'm not saying this is simple because it's new, but when you get it, there's no problems there. There's no trick of what I'm asking you to do. Good. Some of the problems from your homework are equation of a tangent line. You want to do that. Tangent line to the graph. Let's do horizontal, we don't do that. First and second derivatives, let's do this one. Some problems from your homework. Homework. This is number 21. If y equals 4 sine x plus 8 cosine x, and they ask you to find second derivative, you need to find first derivative first. Solution. First derivative, Derivative of sine is plus or minus cosine. Which one is that? Plus. Remember, cosine is a normal dude. It has plus when you differentiate it. 4 survives or not?
Yes.
Yeah.
Survives. It's multiplied, so it's a rate. And you know, actually, I wanted to mention y equals mx plus b. When you differentiate that, it gives you m. It survives. So that's m is a slope. Recognize it? M prime is a slope. So that's where you can also remember if the constant is multiplied by function, it's a rate of change. So it doesn't go away. While b goes away because it was isolated. That is kind of the idea as well. Now, cosine derivative of cosine gives you sine, but plus or minus? Minus. 8 survives. Good. Can you do it for the test? Okay, good. So you see, today I will try to build your confidence. But if you don't feel confident about those problems, my reviews are good. You don't feel desperate if you don't understand this right now. You take notes and you put a big star, and that means you need to practice at home. So you put star if something scares you a lot. You put like question mark if you just need to practice, and maybe you put a check mark if you're confident with that. So that's how reviews are good, that they give you feedback. It's called reflection. And you have to be honest with yourself, because we have this whole study about people who are weak in class or behind in the material. They tend to think that they're this good when they are this good. And people who are strong in class and have self-confidence issues, which are usually minority people, people with, imposter syndrome, oh, I don't deserve to be here, even though you're fine, you're doing good. We think that we are this bad. So we practice more and do better. That means if you think you're very good at this, that might be a trap of your brain. We all have it sometimes. So if you think you're way too good, it might be a trap. Go and practice with closed notes. And then you know. When the notes are closed, everything is good from there. Then you know how you do. Minus 4 sine x. Agree? Do you have questions why? Minus 4 sine. Minus 8 sine. Wait, derivative of... minus 8 cosine. But derivative of sine is plus cosine. So why minus? Because there was already minus in front. Does it make sense? So just be careful with that. That's the answer. If they ask you second derivative, this is the second derivative. Can you do it in a test? Now, equation of the tangent line. Let's do that for sure, because you will need that. So, as I mentioned before, example number 19. There's a 30 problem in 2.3. If you did not start it yet, you're supposed to. You're kind of behind. So find the equation of a tangent line. Find the EQN, that's the equation, of the tangent line. And then if I say on the exam, using any method, then you know what it means? Screw the definition. And then we're going to do example after this with the definition. Then you have to do definition. I know, but it's only once though. Other exams don't have that, so it's good. Only the first exam. So we always give you the function, the curve. It is 4 sine x. And then we're going to give you a point at x equals pi over 6. Do we require you to know angles of trigonometric functions? Yes. We expect you to know it. We expect you to know sine of pi over 6. That's what calculator can help you, but actually we kind of hope you do. At least know 3. Of course, 0 and 1, but at pi over 3, pi over 4, pi over 6. Only 3. Can you just memorize that? For sine and for cosine. And then zeros are kind of easy. 0 and pi, those are easy. Pi over 2. I was always struggling with that, so I don't know if you're struggling too, but it's possible. Solution. This... Ouch. Is it TikTok? Better not be TikTok. Okay. So this problem will show up in calculus 1, 2, and 3. I'm just literally honestly telling you. The earlier you learn it, the less work you'll have in the future. Just be done with this. Learn how to do freaking equation with tangent line. It will be for 3 semesters. So why bother postponing this? Just do it. Just do it. You will save so many grades if you just know this problem. We like putting this problem as a free response because it has steps. That means it's very expensive, usually. So just learn it. You will have 3 points if you know how to do this this problem. Step 1. You see the tangent line phrase? You know how to start. You do what? Find derivative. Y prime, F prime, whatever it is. Find derivative. Okay, I see the function is for sine. Derivative is? 4 cosine x. Yay. Step 2. Well, that's just a derivative, but they wanted to find slope. Slope is the derivative at the given point. So I need to plug pi over 6 in it. 4 cosine, go away, cosine of pi over 6 equals cosine of pi over 6 through root by 2. Oh, root 3 by 2. Agree?
Yeah.
I'm flipping words today. That's so weird. Such a weird thing to do. 4 root 3 by 2. You know what's always confusing? Do you correctly say Scout girls or Girl Scouts? Because both make sense. If you're a foreigner, you have no idea. Are they Scout girls or Girl Scouts? Are they girls who are scouts or are they scouts who are girls? I will never remember that. Simplify. It's going to be 2 square root of 3. Step 3. If they did not give you need to have y sub 0. I don't see it. Actually, in your homework, they gave you. I just did not give it to you right now. Y sub 0 is missing, then you have to find it. So if needed. How to find y sub 0? Plug pi over 6 into what?
Y.
Into original y. Original. Original is for sine. Let me change the color maybe. For sine of pi over 6. What is sine of pi over 6? 1 by 2. So it's going to be 4 times 1 by 2. The answer is 2, right? Correct? Good. Put it in the box. Everything you find, put it in the box because you will be using it. 4th step is literally the answer before you simplify. The formula is, let me put some pink color, y, fat pink color, y minus y sub 0 equals mx minus x sub 0. You can use formula y equals mx plus b if you know how to do it. I don't mind. Just make sure the answer is correct. So this is the idea here. We always give you x sub 0. That's given. Sometimes we give you y sub 0, but if not, you find it by plugging into the original. And then m, you need to find it. So we found it. We have everything. Don't touch y and don't touch x. The answer becomes y minus y sub 0 was 2. M, 2 square root of 3 equal times x minus pi over 6. Thank you. Step 5, simplify. By simplifying, we mean rewrite as y equals blah, blah, blah. Y equals 2 plus 2 square root of 3x minus 2 square root of 3 pi over 6. Simplify that. And the answer becomes 2 square root of 3x. That's the beginning of y equals mx. And now we need to find the b. And the b is not really simple. Oh, it is simplified. No, it's not. The b is just the same thing. 2 minus 2 simplified. So it's going to be, how to write down nicely, pi square root of 3 over 3, I guess. Doesn't matter. That's your b. That is the answer. Can you do this on Wednesday? If not, put a star right now and you better prepare. Don't assume. Also, it has 5 steps. So if your brain tends to freeze during the test, you know what to do. You need to do it again and again and again. And I would do it one more time in the morning on Wednesday. At least that's, as a student, I would do that. I wake up at 6 in the morning, redo the whole review, come to the exam, nail the exam, fall asleep after that. So. But if you're a morning person, that doesn't work. I'm not saying it. Everyone should do it. So it's up to you. Having enough sleep usually is crucial. So make sure you don't fail that part. That's kind of important. That was good. What else did you guys stuck with? I saw this problem. Number 12. F at u. Why they used u? Because why not? Any variable is legal to use. Moreover, mathematicians will like to use x, y, t all the time. So engineers came to us. That's a true story. There's a meetings between engineering department, math department once per year. They mention the critics that they don't like, we don't use any other variables. And then people go to physics and chemistry classes and they're confused with W and all this kind of Jones and Joules and whatever. So because of that, they coded lots of problems with U, D, all the ridiculous letters. So you know whom to blame. We don't like it. As mathematicians, we don't care. It's the same thing. So your brain is supposed to freak out. Okay, find the derivative. Well, it's kind of hard. I don't understand what to do. So let me try to figure out what to do before differentiating. Square root of 5 is fine. Bless you. I don't mind about that. But then how to rewrite square root of 2u? Yes, square root of 2 times square root of u. Is that what you said? I think I heard over here. Square root of 2 times square root of u. Remember, that's a property of the root. If it's addition or subtraction, you cannot do it. Product division, you can. Now, can you still differentiate? Some of us do, but some of us don't like square roots. I usually recommend people to rewrite it as 1/2. You can use a pencil. You don't have to write all of this again and again and again. Use a pencil, write down u to the 1/2. F prime of u becomes, what do you think?
Root 5 plus 1 by 1.
Root 5, what happens to u?
Once.
Exactly, derivative of u is 1, remember. Derivative of x is 1. Plus, and now you have square root of 2 survives because multiplied by the function. 1/2 goes down, and by go down means we're multiplying it. U, and then you do 1/2 minus 1. That's the easy one, minus -1. This is the answer. Don't bother to rewrite it unless it's a multiple choice question. Then sometimes it is simplified. So if it's simplified, you need to just find a simplified version of it. You have multiple choice questions in the test. I put it in there's a sample of the exam. Here it is, sample of the exam I posted. This is the instructions. This is the instructions. So I don't want you to waste time reading this on a test. I feel people who expect you to do it are just a little bit naive. I never read them in the United States. I don't have time to read this. I'm freaking out. So here you go, read it at home. And then this is the example. Multiple choice part, I gave you 2 problems as example. Free response part, I gave you 1. There's a table. This is for me to evaluate stuff. This is example of the test. I felt it was a brilliant idea to show this to students, so you guys don't freak out too much. And any other request before we move on to the piecewise functions and derivative by definition?
Could you teach how to find normal to and
Oh, I have video on that, and I did not put it on a test, so I don't want to.
it's not.
No, most people will not remember it. There's a problem there with a normal, I have video on that, so you can check it. Yes?
Graph.
Oh, the graph, yeah.
Just 1 by n.
Yeah, I don't know.
Slope? Yeah.
Take n and do 1 over n.
Yeah, exactly. So normal line has a reciprocal slope than the tangent line. Reciprocal, negative reciprocal
Oh.
means 1 over m for the tangent, and then you change the sign because they're perpendicular. We can't expect you to know it, but not for the test purposes. You maybe saw it somewhere in pre-calculus class, but usually people just Google. Every time you're stuck on something, probably we expect you to search for it. Just Google. You can do it. I believe in you. Google or call Alexa for help. Quickly before we go to other stuff, equals 7 square root of t plus 12 over square root of t. Very fast with that. Rewrite first. F equals, I'm debating about the graph of the derivative. There's no problem like this on the exam, so I'm not thinking if I want to waste time on this. I can do it in the office hours. They show you the graph of the derivative But it's not on the test, so I kind of like,
If it's just a function, wouldn't you just graph it the way you would any other function?
It's what if you don't have a function and you need to make it from the graph of the original? That's what they have in the homework. I think that's what he means. Do you see what I did? That's the hard part. Not only I know it's a square root, so it's going to be 1/2, but it was in the denominator, so negative sign shows up. Does it make sense? You see roots, get rid of them. Slowly, if you want to see how it works, it was like that. 12 over t to the 1/2, right? And then you see it's minus 12 t to the, no. And then you see it's 12 t to the minus 1/2. So I guess this is required. We assume you know this. Let's check lecture 0. I did cover it there. Derivative is 7 stays. 1/2 goes down. T to the minus 1/2, we had this before. Plus 12. Minus 1/2 goes down. T minus 1/2 minus 1. And then you take a pencil and you calculate. Minus 1/2 minus 2 over 2 gives you minus 3 over 2. Make sense? That is the answer. Find it. I guess let's simplify. If it's multiple choice, it will be 7/2 t to the minus 1/2 minus 6 t to the minus 3/2. Find this in the multiple choice. Doo-doo. Good? That's 2.3. I think that's the last one I want to show, because the last 10 problems there are find velocity, acceleration, tangent line, tangent line, tangent line. We solved many of those questions in the forum. So check the forum. It was very active yesterday. I helped a lot yesterday. Well, I'm always helping because I'm very nice. But there was a weekend yesterday, so I actually spent time yesterday to make sure you got your homework. This is good for 2.3.